This week I'm going to continue on mandatory access control second session, or the second part of this mandatory access control lesson. And if you remember, I completed the first part in the last session that we had. I will quickly go through the slides that we discussed last time as well. So let me start with that. So we discussed when discretionary access control fails, and then discretionary access control and role-based access control, and we discussed the requirement of mandatory access control. So mandatory access control is basically policy-oriented. It's a centrally governed access control mechanism. And we call it very rigid because there is no any other way to avoid the access control principles other than the policy definitions. So when we discussed use case, there is a hierarchy of security levels that we discussed in mandatory access control. So top secret is the highest level, and they are secret, confidential, and unclassified. So it is not necessary to follow the same security levels. You can define the security level according to your organization's requirement. So this is just an example. So when we have a hierarchy, so the information will be shared across all the users based on the user's clearance level, and comparing the data item or the data object's security level. So if both the security level and the clearance level of the user matches, then we can provide this authorization. So when it comes to multi-level relational model or multi-level security model, we introduced two important security principles, so security mechanisms that is followed by these multi-level security models. So that two principles, we call it simple security property and star property. So we used a lattice-based model to understand the complexity of this problem that we are trying to address. So lattice-based access control models organize security levels and permissions into a particular structure called a lattice. So this lattice structure is originally presented or discussed in the context of mathematical structures. So these structures are used in multi-level security models to present the problem in a more precise manner. So here each point or each node in this lattice represents a particular security classification or clearance level, and relationships between these points define what access is allowed. So here this is a sample lattice, and these are called labels, right? So these are labels, and within these labels we can find the data items sensitivity level, right? So top secret, secret, right? And sensitivity level coupled with a compartment, which is the data item or the data source that we are going to refer. So we see that there can be different combinations of sensitivity level and compartments. So according to this lattice, it defines whether we can consider a particular uh, combination. So BLP model, which introduced this simple security property and star property. So the simple security property is about reading, how we allow reading, and star property is about writing, how we allow writing. So simple security property says a user cannot read beyond the security clearance level that she is assigned. So which means basically the users are denied reading any data which is classified higher than their own classification level. So no read up. Users cannot read higher security level data items. So star property is about writing data. So users cannot write data to be read by any user which is lower than the classification level of the particular user. So we call it no write down. The writing data to lower levels is prohibited. So then we discuss multi-level relational model. So multi-level security in relational model. So we know that relation is particularly a table-like structure in a database, relational database. So in a typical relational database, yes, it's not a big issue to maintain all this data, but when it comes to multi-level relation, there is a challenge where we have to maintain uh, data for different levels because the users might be in different clearance levels. So if we take a multi-level relation, we represent the relational schema of a relation in this way. So it comes as a series of attribute classification pairs, right? So this is the attribute 1 and its classification, attribute 2, its classification, attribute n and its classification, and TC is the overall classification of a tuple. So if you think of a typical relation, right? So we might have several columns, attributes. So in a typical relational model, but when it comes to multi-level relation, so each of these attributes are coupled with classification C1, C2, C3. And apart from that, additionally, we might have a TC, which shows the individual tuples classification. So if we think of a tuple like this, right? So whatever the attribute here, there will be a classification, right? So it can be secret or it can be top secret, right? So it can be any other level. So then we discussed relation instances over R. So if we take a relation R, there can be multiple relational instances which comes from the relation that we refer. So if there is a relation R, there can be multiple relational instances for different clearance levels. So if we uh, think of a hierarchy of clearance levels, so there can be top secret, secret, confidential, and maybe unclassified. So that might be the hierarchy that we are interested. So in that case, our relation R might have different instances in RTS, RS, RC, and RU as well. Because for the same relation, we might have different instances for different clearance levels, because the things that we see as a top secret user might not be available for a user in secret level here. So things that is available in this relation for secret level user might not be available for uh, confidential level user. So that is how it works. So everything that is available for confidential level user will be available for secret user, because that is higher in the order or the hierarchy. But the higher the data available for the higher level users will not be available for lower level users. So that is what it means. So we introduced a term called apparent key. So we refer this, I mean, we use this term apparent key. So that is somewhat equivalent to primary key in uh, usual or ordinary relational model, because you know that in a typical relational model, what primary key does is it uniquely identifies tuples or maybe rows in the table. So, so that is the purpose of primary key. Uniquely identifies or maybe differentiate rows among all the rows. So that is the purpose. But when it comes to multi-level relational model, uh, this set of attributes alone will not be able to uniquely identify a row, because you know that for each attribute there is a classification level as well. So whatever the attribute set that uniquely identifies a row in a usual or ordinary relational model will not be able to identify the same row in the multi-level relational model, because there are some other attributes, though, or newly introduced attributes called classification levels. So we need the help of those classification levels to identify these rows uniquely. The thing is, we discussed a concept called polyinstantiation, where the same entity is represented in uh, multiple tuples with different classification levels for different user level uh, user levels, right? So if you think of a employee table, right? If you think of a employee table, right? Employee ID, name, and perhaps we have many more attributes. So employee ID 3 and minimal and all the other values. So if we bring this relation to a multi-level relational model, we will have classification attributes as well, right? So each of these attributes will have its own classification level. So this minimal or employee ID 3, right? So this might be maintained in two different security levels based on the data we are going to maintain, right? For there can be top secret users who sees different information compared to the users who are in confidential level, right? So it's about the same NIMAL or same employee with employee ID 3, but the relational model might need to maintain two different tuples, two different roles for these two classification levels. So in that case, the employee ID alone cannot be considered as the primary key here, because employee ID 3 might appear 2 times or maybe 3 times, right? So in that case, employee ID alone cannot be considered as a primary key. So what we do here is we give a different name for employee ID in a multi-level relational model. So that is what we call apparent key. So apparent key is the primary key if we bring the same relation into ordinary relational model without classification level. So in that case, we call it primary key. But if we bring the same relation into multi-level relational model, the same key will be called apparent key. Yes, as a result of BLP properties, right? So BLP is the Bell-LaPadula model that we discussed. Users having different clearances see different versions of multi-level relation. So if there is a relation R, users having different clearances right? So we'll see different versions or different instances. We call it instances. So a user having a clearance at an access class C sees only that data which lies at class C or below, because we define this hierarchy. Top secret is higher, secret, confidential, and unclassified. So we call it element tuple TAI. So in a relation, right? In a relation, if we take a tuple, any tuple, right? So this is our relation, and this is our tuple T. Tuple TAI refers to, if we take any attribute AI, or maybe the ith attribute, we can take it as AI. So TAI refers to the value given here, right? TAI is here. TAI is here, right? And TCI is the classification level. So this is tuple T's. This is TCI, the classification level of tuple T's ith attribute. Right? So that is TCI. So it says element TAI in a tuple T is visible in instances at access class T, CI or higher, which means whatever the value given here will be visible to instances derived from this relational model in the classification level given here, TCI, right? So this value here will appear, which means TAI will appear in all instances, including RTCI or above, right? So that is what it says. Tuple TAI is replaced by null values in an instance at a lower access class. So if any lower level instances, if we consider lower level instances compared to the classification level given here, so those instances, this value will be replaced with null value, because this is not allowed to see by users who are below the classification level given here. So multi-level relation is something like this, right? So attribute ID is the apparent key here. Let's assume this apparent key here is attribute ID. So if you execute select asterisk from employee table as a S user, right? So that user will so that S user will see everything, because there is nothing, no attribute value which has higher classification level than S, right? No TSS, right? So higher than S is here, higher than S is TS. So therefore, you can't see the top secret classification. Therefore, a secret user will see everything. But the same relation, if queried by a user in confidential level, so that user will not see certain values which is in secret level. So those values will be replaced with null values. A user with clearance level U, so that user will see only this, right? With lots of null, right? The third row is completely gone. So then we introduce the term or the concept polyinstantiation. So that is basically there might be necessity to store two or more tuples at different classification levels with the same value for apparent key. So having the same value for apparent key is in real world phenomena that we refer is the same. So if it is an employee table, we are referring to the same employee, but we are maintaining two or more tuples, two or more rows in the relation. That is because different classification levels. So these tuples, these rows might have different classification levels. So two possible cases for polyinstantiation. One is a user with low clearance, which is like a lower level user, which does not has much more sensitivity to the data. So a user with low clearance insert data to a field which already contains data at higher or incomparable level. So if a lower level user attempts to insert data which is already in higher level, so in that case, we can't modify higher level, we can't allow modifying this higher level data item by the lower level users, right? So we have to maintain multiple copies in that case. The second scenario is a user with high clearance level or higher level user inserts data in a field which already contains data at lower level, right? So in that case too, we cannot allow it to happen, modify. So polyinstantiation, several tuples can have the same apparent key value but have different attribute values for users at different clearance level. So the two types of uh, polyinstantiation we discussed earlier. First one was lower level user attempting to modify data which is already in the higher level. And the second scenario is higher level user attempting to modify data which is already in the lower level. So those two cases, invisible polyinstantiation and visible polyinstantiation. So invisible polyinstantiation is the polyinstantiation is invisible for the user. So in that case, lower level user attempt to modify data which is already in the higher clearance level. Visible polyinstantiation is the user sees these multiple instantiations of the tuple. That happens when a higher level user attempting to modify data which is already in the lower level. So this is an example scenario for polyinstantiation, which is invisible polyinstantiation. So user with clearance level U, which means the lowest clearance level. So the user has this lowest clearance level and attempts to insert this particular data. But if you consider the apparent key here, apparent key is ID, and the same apparent key appears here in the relation with a higher classification, right? So this row is invisible to the particular user. So he or she attempts to insert the row with same ID. So what happens is this row will be inserted to the relation and maintained in a different clearance level U, but the original or previously stored data will remain in the relation. So we call it polyinstantiation, multiple copies with the same apparent key. In this case, it is invisible to the user, so we call it invisible polyinstantiation. Visible polyinstantiation case scenario, a clearance level S, a user with clearance level S, somewhat higher in the hierarchy. So now the same user is attempting to insert this. However, the same apparent key appears here in the lower level, right? So when the user attempts to insert, that row will be inserted as a new row while keeping the previous data item. So that is again two rows with the same apparent key, right? So this is called polyinstantiation, and it is visible to the higher level user because this S user will see both tuples. Therefore, it is visible polyinstantiation. So that is what we did last time. It's a summary of what we did. Let me share the slides for today's lesson. Right. So today we are going to look at integrity properties of multi-level relation. So when we have multi-level relations, how can we maintain integrity? Because you know that when we have multi-level relations, we have one particular consideration is it's not like ordinary relation because we have multiple instances of relation like RU, RC, or S, and or top secret TS. So there can be multiple instances. So among these instances, there should be consistency, right? Integrity. So that is a one integrity concern. And the other thing is the concept we call polyinstantiation, maintaining multiple copies. So that is again another concern. How shall we maintain the consistency integrity when we are keeping multiple copies of the same data item in different levels? Okay, let's start. So integrity properties of multi-level relations, it's in a standard relation, if you think of a standard relation, there are certain mechanisms that has been enforced to ensure the integrity. So if you consider a typical relational database, right? Not a multi-level relational model, a single level or typical ordinary relational database model, they are, in order to maintain the data integrity, they have introduced certain concepts, certain mechanisms. One thing is primary key of a typical relational model. So the primary key ensures the uniqueness of data. And then there is a foreign key constraint, so the referential integrity. So it maintains the integrity among the data items that has been shared among different relations. So that is about referential integrity. And apart from that, there are so much of other constraints, other rules that have been enforced through constraints. So in a multi-level setting, the concept of these constraints are defined in a bit different way. So if we look at, since a multi-level relation has different instances and different access classes, it is inherently more complex. Updating an instance should not make other instances inconsistent or unreliable. So when we have multiple instances, so if you update this particular instance RU, it should not make inconsistent all the other instances. And same way, if you update here, this instance, it should not have any integrity violation of inconsistencies with any other instances. That's why we need to maintain integrity specifically, and we may have very specific requirement to maintain the integrity. Single level relation or standard relational model, we have keys, right? We have keys, but the prime concept of called primary key is not so valid when it comes to multi-level relations. So that's why we refer the same key in multi-level relational model as apparent key. Yes, the term integrity in databases. So integrity is the assurance that the data stored in a database remains accurate, consistent, and reliable over time. And if we come to standard single level relational model, there are several integrity principles in standard relational databases. So what are those integrity mechanisms in standard relational databases? One is entity integrity, and the second one, referential integrity. Third, domain integrity, and fourth, user-defined integrity. So user-defined integrity is the relational model allows users to define their own rules, constraints to maintain domain-specific or problem-specific integrity requirements. Entity integrity, right? So entity integrity. Okay, let's see what these are. So the entity integrity is it ensures the uniqueness among the data items that we are going to store in this table, right? So it ensures the uniqueness of entities within a relation, right? Within given table, how we can differentiate the rows. That uniqueness is enforced through entity integrity. So when it comes to entity integrity in a standard relational model, that has been enforced through the concept called primary key. Primary key uniquely identifies each and every row, right? Uh, Key points, uniqueness, right? So each row should be unique, and these primary key attributes should not contain null values, should not be null. So that not null constraint ensures that each row or the each data item that we are going to store in this table is properly identified and differentiated from other data items. So if we take typical standard relational model, this entity integrity is enforced through primary key constraint. And again, the second integrity principle is referential integrity. So I said earlier, so the referential integrity is about ensuring the values of foreign key attributes in a table correspond to valid primary key values in another related table. So when we are referring values, referring data in a different table, how we can ensure the consistency and the relatedness between two data items. So that has been maintained through referential integrity. So in a standard relational database, foreign keys are employed in maintaining the referential integrity. That is how those referential integrities are maintained in standard relational data model. Domain integrity is basically it's about ensuring the validity of data that we are going to store in a particular attribute against the domain definitions. Yeah, as given here, it enforces conformity of data to the defined type or format, right? So if you attempt to store a string data type into a table where the attribute is defined as an integer, you will not be allowed to store it. You will be prohibited. So that is domain integrity. So you cannot store strings in integer type data. You can't store integers in data type date type attributes. Likewise, that defines the domain of the data. So the user-defined integrity is about we define our own custom integrity constraints. Right, so that is about standard relational model and its integrity principles. Next is we are going to look at what is meant by integrity and what sort of additional integrity concerns are required when it comes to multi-level relational modeling. So when it comes to multi-level relational model, there are few integrity properties that we are discussing with respect to multi-level relational model. One is entity integrity. So that is something we discussed in the context of standard relational model as well. So it appears in multi-level relational model as well, entity integrity and null integrity, right? So null integrity, as its name suggests, it's about dealing with null values. Inter-instance integrity, right? So as its name suggests again, it should be something about maintaining integrity among multiple instances, right? And polyinstantiation integrity. So when we are keeping multiple tuples of the same data item, same apparent key, how to ensure the integrity. So that's how those are the things that we are going to discuss under integrity properties of multi-level relations. Okay, let's take entity integrity. So in standard relational model, when it comes to entity integrity, it is about the uniqueness, right? So that entity integrity has been enforced through primary keys, right? So primary keys, when we are enforcing this entity integrity, it appears that uniqueness must be there, right? So each primary key should be unique among the tuples, and you cannot have null values as primary keys, right? So that is how it is maintained. So when it comes to entity integrity in relational, multi-level relational model, right? So multi-level relation, it says all attributes that are members of the apparent key must not be null, right? So apparent key members should not have null values. So that is one condition, and must have the same security classification, right? So let's say if we have three attributes and combine to make a apparent key, let's say A1, A2, A3, right? So these three attributes together make the apparent key for a particular relation, right? And all these attributes will have their own classification, C1, C2, C3, right? And there will be so many attributes later. So this is our apparent key and its classification. So the first condition says, in order to ensure or in order to enforce entity integrity, a relation should confirm this requirement. What is the requirement? That is, apparent key must not be null. So whatever the values that we see as apparent key should not be null, and all their classification levels should have the same classification for each row, each tuple, right? So that is the first condition. And the second is all other attribute values in the tuple must have a security classification greater than or equal to that of the apparent key. So all the attributes here, right? All the other attributes, you see, it might be A4, A5, and so on, C4, C5, and so on. So all these other attributes should have a classification level greater than or equal to that of the apparent key. So their classification level here should have either the same classification level like here or higher, right? So if it is confidential, these values should have classification level of confidential or secret or top secret. It should not be unclassified, right? So that is what it says. So this constraint ensures that a user can see the key if the user is permitted to see any part of the tuple, right? So if a user sees any part of the tuple, the same user will see the key, so apparent key. So that is the important part. So if apparent key is visible to a user, if the user sees any other part of the tuple, right? So that is entity integrity in multi-level relational model. So we can show this, we can describe this entity integrity in a more formal mathematical notation. We call that multi-level relation R satisfies entity integrity if and only if for all instances RC, right? So for the relation R, there can be lots of relation instances. So for any instance, or for all instance RC of R, and if you take a tuple of RC, right? T is a tuple from relational instance RC, and its apparent key AK of R. So it should confirm these rules. What is the first one? For all attributes who are part of apparent key, all attributes who are part of apparent key should not contain null values, should not contain null values, right? So all tuples, their apparent key attribute values should not have null values. So that is how we call it here. And if we take two attributes who are member of apparent key, I and j, two attributes of apparent key, and their classification level, TCI and TCJ, should be the same, equivalent, right? So apparent keys classification levels should be the same, equivalent levels. Right? So that is the second condition. And the third condition is any other attributes who are not a part of apparent key, right? Not a part of apparent key, their classification level should be higher than or equal to apparent keys classification level, right? So that is what it means. So the textual form and more formal mathematical notation, entity integrity. So entity integrity basically it says you cannot have null values to apparent key attributes, and apparent key attributes should have the same classification level. You cannot have different classification levels for apparent key members. And the third condition is all the other attributes who are not a part of apparent key should have a classification level higher than or equal to apparent keys classification, right? So this constraint ensures that a user can see the key if the user is permitted to see any other part of the tuple. So it is not the other way. It is important to note that it is not the other way, such that user can see other attributes if the user can see the key, right? So you may not see all the attributes if you see apparent key, but if you see any part of the tuple apart from the apparent key, then it ensures that you see the apparent key. Right? The second integrity constraint is null integrity. So this is about how to ensure integrity in a relational model with multiple security levels when you have null values. So semantics of null values in multi-level relation are important. So there are two major issues. The first is the security classification of null value. So what is the security classification if there is a null value? And the second concern is subsumption of null values by non-null values, right? So what is this subsumption? So subsumption is, it is said that if there are two tuples T and S, two tuples T and S in a relation R, right? It is said that tuple T subsumes tuple S if for every attribute AI, either tuple T's AICI pair is equivalent to AICI, or tuple S attribute AI value is equivalent to null, while tuple T's the same attribute value is not null, right? So in such case, we call it T subsumes S. That is, tuple T and tuple S agree everywhere except possibly for some attributes where S and S has null values and tuple T has non-null values with the same classification, right? So it's a scenario like this, right? Let's say we have a relation. Tuple T is like this, right? Tuple T. Here is tuple T. We have value X here, Y, Z, A, B, C. And we have tuple S here. This is tuple T. This is tuple S. Tuple S as X here, Y here, Z here, null here, B here, and C here, right? So except for this attribute, all the other attributes are the same and with their classification levels, right? I didn't draw the classification levels for these attributes because that might make this entire drawing a complex one. So except for this particular case, all the other attributes are same for tuple T and tuple S, and for here, this has a value A and it is null here in tuple S. So in such scenario, we call that tuple T subsumes tuple S. So the term subsume means include or absorb, something like that, right? So in a relation, if you have identical value for all the attribute except some attributes which are having null values for one tuple and non values for the other tuple. So in such scenario, we call that tuple T subsumes tuple S, right? So RC, which is C instance of relation R, is said to be subsumption free if it does not contain two tuples such that one subsumes the other. So if there are no such tuples in a relational instance, we call that relational instance is subsumption free, right? We call it is subsumption free. For the example we took here, this one, it is not subsumption free because there are two tuples T and S here. So one is having XYZ ABC, the other one is having XYZ null BC. So this is not a subsumption free relational instance. So if there is a relational instance which does not have such subsumption, we call that relational instance is subsumption free. So let's go back and look at null integrity. So in null integrity, it addresses two concerns, two issues: the security classification of null values and the subsumption of null values by non-null ones, right? So that is what null integrity ensures. Let's see what null integrity is describing, right? A multi-level relation R satisfies null integrity if and only if for each instance RC of R, both of the following conditions are true. So we call a relation R satisfies null integrity if and only if its all relational instances following these conditions. There are two conditions. If both conditions are followed or adhered by all the relational instances of relation R, then we call that relation R satisfies null integrity. Okay, let's look at what are those conditions. So those conditions for all tuples, for all T, which is a member of relation instance RC, which means all the rows, all the tuples of instance RC, if there is a attribute that has value null, then its classification, right? Its classification, if there is an attribute AI that has a null value stored in a tuple, so that attribute's classification, TCI, is given the classification of apparent key. So if there are null values in the particular relational instance, that null values classification level is given the classification level of apparent key. So nulls are classified at the level of apparent key. So that is how we give the security classification for a null value. The second one is instance RC is subsumption free. So relation RC should not have any subsumption, right? So we discuss what is subsumption here. If there are two rows that has identical values except for some attributes where one has null values and the other one has non-null values, right? That particular scenario should not be appear in any instance, right? So if those conditions are satisfied, then we call that R satisfies null integrity, right? So what are those two conditions? First one is null values are classified in the same classification level as apparent key, and the relation instance should not have subsumption, right? So if this has to be happen, all relations are made subsumption free by exhaustive elimination of subsumed tuples. So in order to make sure that this condition is satisfied, we have to eliminate all subsumed tuples. So let's say a S user will update address and set it as Dehival, right? So the user's level is S, which is somewhat higher, right? TS, S, confidential, unclassified, right? So now this S user, right? S user update address and set it to Dehival, right? Right now it is null value, right? So if this relation follows entity, null integrity, then what should be happen is it should change this null value into Dehivala and its classification is changed to S, right? Or perhaps you might be thinking, what if we maintain multiple copies or polyinstantiate, right? So instead of removing this, we maintain multiple copies, right? So this is basically, we need to eliminate subsumption, right? All the attributes are same except for a particular attribute, right? So one is null value and the other one is not null. So this is not free from subsumption. So we have to eliminate subsumption. So once eliminated, we will have this, right? So it does not make any problem to users who refer this relation with classification level U, because if a classification level U user attempts to see the data, this will not be available. The Hibala will not be available because it's in the different level, S level. So that data item will not be seen, visible to this user. So that will be set to null before it is appearing in user's side. Next is inter-instance integrity. Inter-instance integrity, right? So inter-instance integrity, as its name mentions, it's about maintaining the integrity among multiple instances, right? So there can be multiple instances. So how can we maintain the consistency between different relational instances? So what inter-instance integrity says is, if there is a relation R and there is a hierarchy of classification where C dash is inferior to C, C dash is lower level to C, right? So if we derive RC and RC dash, right? RC and RC dash, according to this hierarchy, all the data which is visible to RC dash is appearing in RC because the level C is higher in this hierarchy. So whatever RC dash sees will be visible to RC as well. But everything visible for RC is not visible for RC dash because there can be data which is not visible for RC dash. C dash is lower, right? Therefore, everything contains in RC dash is available in RC, but the other way is not the case, right? So whatever you see here will appear here, but everything appear here will not available here, right? So then what we can do is, if the hierarchy is like this, then we should be able to derive RC dash, right? RC dash from RC, right? Because everything that we can see in RC dash is already available in RC, then there should be a way we can filter the content that we can see in RC dash from RC, right? So we can derive RC dash from R. We can derive RC dash from RC because RC is the higher level compared to RC dash. So if there is a filtering function sigma, we will be able to filter the relevant data from RC to RC dash, right? So we can write it like this: RC dash can be derived through a filtering function by providing higher level instance RC and providing the filtration level C dash, that is the level that we want to filter out things, right? So we provide a high level instance and the level that we want to filter, C dash. So this function, then we will provide the relevant instance. So we call that R satisfies inter-instance integrity if and only if for all C dash lower than or equal to C, we have our C dash instance which can be derived through a filtration function sigma by providing higher level instance RC and filtration level C dash. So filtration function sigma produces the C dash instance RC dash from RC as follows, right? So for every tuple T, for every tuple T, which is a member of RC, right? RC is the higher level instance, such that the classification level of apparent key in that tuple T is lower than or equal to level C dash, then there is a tuple T dash in RC dash, right? So what it means is if there is a tuple in RC, so RC is the higher level, RC dash is the lower level, right? Lower level instance. So if there is a tuple in RC here, tuple T, such that the tuple's apparent keys classification, apparent keys classification is the classification level or the lowest classification level we can see in that tuple, right? So if tuple T's apparent key is lower than or equal to C dash, then there will be a corresponding tuple in a RC dash instance because apparent key is having lower than or equal classification level to C dash, right? If that happens, then tuple T dash, which is the tuple appear in C dash, apparent key and its classification is equivalent to tuple T's apparent key and its classification, right? And all the other attributes who are not a part of apparent key, right? So tuple T's attribute AI, CI pair attribute and its classification value pair will appear in tuple T dash if this tuple T's classification level Ci is less than or equal to C dash, right? So all the data attributes that are lower to C dash will appear in the tuple, right? That's what it means. All the data which appears in RC that has higher classification level than the C dash will not appear in C dash instance. Instead, what happens is those attribute values will be set to null and its classification will be set to apparent key classification, right? So that is how the correspondence. And there are no tuples RC dash other than those derived by the above rule. So apart from this mechanism, there won't be any other tuple that appears in RC dash. So this is the only way that you can derive tuples to RC dash. Then third, the end result is made subsumption free by exhaustive elimination of subsumed tuples. So if there are subsumed tuples, that will be eliminated at the end. So this is called inter-instance integrity. So that will ensure that if you take two instances, RC and RC dash, the integrity is maintained through maintaining the consistency. Two additional properties of inter-instance integrity is so if you have instance RC, right, and you have the filtration function, and you apply filtration function to this RC by specifying the filtration level you want to filter is C, which means the same level. So if you do this, you will have the same RC, right? Sigma with this, right? So if you try to filter out tuples that belongs to this level, so that will result the entire instance itself, right? There won't be any filtration. So that's what it means. And the second condition is if you try to filter out C dash level from RC, that which is C dash is lower level than C, that will result R C dash, right? This is one. And again, if you apply sigma to this by specifying C double dash, which is somewhat lower to C dash, right? That will give or C double dash, right? So the same result we should be able to derive directly if we apply sigma or the filtration function by specifying C double dash, right? So either you apply C dash first and then C double dash as the next step, you will have C double dash, or else you can directly apply the filtration function by specifying C double dash, so you will have the same result. So let's see what it means. S user, a user with S classification level will see the entire relation given below because every data is either in level S or below. So the user S user will see everything. A U user will see the filtered instance given below. So U user will not see the entire data items because this is in S level, so that will be set to null, right? So the filtration. So again, S user will see the entire relation given below. So this entirely will be visible to S user, right? Because S is higher than confidential and unclassified. So everything will be visible. A U user will see the filtered instance given below. So U user will not be allowed to see this, right? This will not be allowed, right? So these are not allowed, right? So what happens is a U user will see only this version of the relation. Next is polyinstantiation integrity. So we first did entity integrity, next null integrity, then third inter-instance integrity, fourth polyinstantiation integrity, right? So this is about maintaining multiple copies of the same data item, which means multiple tuples with the same apparent key. So we call that relation R satisfies polyinstantiation integrity if and only if for every relation instance RC, we have for all attributes AI is determined or maybe uniquely defined based on the apparent key attributes and apparent key attributes classification, and attribute AI's classification, right? So this property specifies that the user specified apparent key AK in conjunction with its classification attribute CAK and the classification attribute of the attribute AICI functionally determines the value of AI attribute, right? So functional dependency here means we will not be able to find two attribute values for AI with the same AK, CAK, CI combination, right? So following instance does not confirm polyinstantiation integrity. Why? If you carefully look at apparent key here is ID, right? Both rows has the same apparent key and the apparent keys classification level, right? And attribute name is Kamal here, it is Nimal here. Both Kamal and Nimal has the same apparent key and its classification level. And its classification level are also the same. So this is impossible, right? There cannot be two data items with same apparent key and apparent keys classification and attribute classification. Right? So this violates the uniqueness property, right? So this does not confirm the polyinstantiation integrity. So this is said to be confirming the polyinstantiation integrity, even though it has the same apparent key and its classification level, attribute name and attribute name value, Kamal and Nimal has different classification levels. Kalania and Candy has different classification levels. So this is not actually a violation of polyinstantiation integrity. So here you see that primary key in a multi-level relational model is not actually determined by the apparent key. So what we can look at as primary or somewhat similar behavior of a primary key is exhibited by combining apparent key and its classification level and the particular attributes classification level together, right? Yes, here you see primary key in multi-level relation. Polyinstantiation integrity define the form of primary key in a multi-level relation, right? So PKMLR is primary key in a multi-level relation determined by the union of primary key of if the same relation is in the single level relation, single level scheme, which means the apparent key combined with CAK, apparent keys classification, combined with the set of classification attributes for all data attributes not in apparent. So non-apparent key attributes classification level. So this is what we call and something we can taken as primary key in multi-level relation. So this combination will determine the non-key attributes. Next is data modification operations in MLR. With respect to data modification, three operations that we think or we can consider is insert, update, and delete. So those operations are the operations that is going to modify data. If a user with clearance level C sees and interacts with the corresponding instance RC of a relation R, relative to classification level C, R can be categorized into three cases, right? So if there is a R relation R with respect to classification level C, there can be three cases that we can classify instances. So those three instances are uh, instances C dash where C dash is inferior to C. C dash is lower to C, right? So that instance. And we perhaps take C double dash here. C double dash such that C double dash is superior to C, right? C double dash, right? Instance C double dash contains all the instances, all the data, all the tuples which are superior to classification level C. So that is another possible instance. Third, which we did not discuss a lot, that is there can be incomparable. So in a typical classification hierarchy, we took it as top secret, secret, confidential, and unclassified. But there can be a very complex hierarchy that we cannot compare, right? We cannot compare. In such cases, right? Instances incomparable with C. In such cases, we can take is triple dash. C triple dash is incomparable with C. So those are the instances that we can imagine. One instance which is lower than C, higher than C, and incomparable. So if we are going to update, we have to ensure the star property, which means no write down. a C user, which means a user with C level, confidential level, cannot insert, update, or delete a tuple directly or indirectly in any instance RC dash where C dash is lower than C or incomparable to C. So you basically, it means you cannot write data that can be read in lower level users or incomparable level users. So the effect of insertion, update, or deletion must be confined to those tuples in RC. So whatever you do, write operations should confine to tuples in RC, your own level. So insert operation, general form of insert statement. So usually what we do in insertion is insert into, we declare the attributes, right? So in hence, since it is here, it is multi-level relation, so we have to specify RC, which is the relevant instance for a C-level user, and attribute AI, AJ, or whatever the attributes, and corresponding values. So this level C is determined by the user's login class. So whenever the user is logged into the database, the level will be determined automatically because all these user logins are given with these levels. So these attributes classification level for each attribute are implicitly given the value C, because level C user is inserting, so all the classification levels should be that user's classification level. So let a tuple T be the tuple such that tuple T's attribute AI is equivalent to simple AI. If attribute AI is included in the attribute list in the insert statement, TAI is null if AI is not in the list. So if the user specifically mentioned attribute AI and the value simple AI in insert statement, so that will be taken. If the attribute is not mentioned in the insert statement, so null value will be set. And the classification level for all these attributes will be set to user's classification level. So insertion of tuple T is permitted if and only if tuple T's attribute value is not null for all the apparent key members, right? So all the attributes who are members of apparent key should not have null values. And also, there shouldn't be any other tuple that has the same apparent key as T in the instance RC. So let's see some examples. So relation EMP as follows. So this is the original relation. And if user U, which means the lowest level user, execute the following insert statement, insert into EMP values 5 minimal goal. So that will be inserted, right? There won't be any problem. However, if S user, secret level user, attempts to insert data into the initial instance with the following statement, 3 Nima goal. So now it contains this apparent key already. So in this case, where we need poly instantiation, right? In this case, there are two options. One is reject, prevent user intended objective. The second is accept, allow tuples with the same apparent key as below. So this is called visible poly instantiation, where S user sees that both copies appearing. U user attempts to insert data into the following instance. The user sees an empty relation since clearance U when the following statement is executed. So user will not see anything here because all these data are in S level. So user enters this, the same apparent key. This will result again invisible poly instantiation. The user does not see that multiple tuples with the same apparent key appears. Update operation. So when we are doing the update operation, this is the general form of the update statement that we can execute. So C, the classification level C can be determined at the time of user login. So P is the predicate, which means the condition that we are going to enforce when we are setting attribute values doing the update. So let's assume you user make the following update, the above EMP relation. So this is the original relation, and update is executed by U user, lowest level user, and address is set to Navala where ID is 3. So ID is 3, address Navala. So it will result this is updated. So this is a different relation. So apparent key is 3, name Kamal, but the address is in a different or the higher level. So this U user does not see it. U user attempts to update address field of this tuple and set it to Navala. So this will result again poly instantiation because you cannot modify already existing data because it overwrites. So this should not happen. And originally the U user does not see this decimal value. That's why the user attempts to modify it to add now. So what happens is when the lower level user is attempting to modify, it maintains multiple copies poly instantiation, and it is called again invisible poly instantiation because the U user does not see these both tuples, only sees the tuple associated with its own classification level. So let's say S user invokes the following update on the above instance. So update set name Mike where ID equal 3 and address equal deliverer. right? So now this will be affected. So this row will be set to Mike and the Hivala with updating the corresponding classification level. S user invokes the following update on above instance. So S user is doing the update. Mike, where ID equals 3. So what happens here is this is what you users will see. It should not be modified. It should remain. So it will remain in the modified relation, right? Then so it remains without changing. So all the um, what this S user attempts to do is set name equals Mike where ID equals 3. So both rows here is ID is 3. So in that case, both these tuples will be updated like this, and the tuple with classification level U will also be maintained in order to show it to lower level users. So lower level users will not see any difference from the previous case. So it's again polyinstantiation. So this is an arguable scenario where we may need to interpret carefully because sometimes this looks controversial. The first two tuples here, resulting relation due to polyinstantiation of the first tuple of the first relation. The third tuple of resulting relation is due to the normal replacement update of the second tuple of the first relation. So if this is the relation and you user invokes the following update, there won't be any problem where I just update the name into my. And delete operation. So you can delete from instance, which is applicable for your own classification level where condition can be specified as a predicate. But aligning with the star property, only those tuples T that additionally satisfy TC equals whatever the classification level of the user are deleted from RC. Also, in order to maintain inter-instance integrity and polyinstantiated tuples are also deleted from whatever the instances where that instance is in higher level than user's classification level. So if a tuple's apparent key is in classification level C, then any polyinstantiated tuple in R C dash, where C dash is greater or higher than the level C, will be deleted from RC dash. And so the entity that T represents will completely disappear from the multi-level relation. So just to summarize things, some of the concerns in mandatory access control. Write-up allows destruction of more secure information, right? So when we are writing, it does not allow writing lower levels. We allow only writing for our higher levels. So that's a concern. Write-up allows destruction of more secure information. You can write or modify things to the higher levels. There can be solutions that we can discuss for this, alternatives. Write-up means cannot send information to lower level subjects. So when you want to send information or information to the lower levels, when you want to pass some information to lower levels, it is impossible because it does not allow writing to the lower levels. And this hierarchical security levels is too restrictive that we saw that it is too rigid. It does not allow writing lower levels, reading higher levels. And Oracle provides some sort of a mandatory access control like facilities in their database management system. So that in Oracle context, that is called Oracle label security. Labels are maintained against rows and users, right? So it works by comparing the row label with users label. So it's same as classification and clearance concept that we discussed. Users are given labels and rows are given labels. So when a user is attempting to access a row, so these labels are compared and restrict sensitive information to only authorized users. It is based on multi-level security requirements. So Oracle provides the feature to a certain extent. Right, so that's all about mandatory access control, and it's highly theoretical concept, and we are not going to look at how we can implement things as it's much more complex to implement it in a practical scenario, finding an appropriate database management system and configuring it to be somewhat complex task. Right, so if you have questions, we can discuss it now. Right, it seems there are no questions, and I'm going to end this session. And thank you very much for joining, and good night.
Thank you, sir. Good night.